Okay, this is an introduction for the fourth lab. It's about forces and acceleration. And what we're going to kind of first figure out is forces cause accelerations. Woohoo! Now, what we can technically do is we can say, well, I know forces cause accelerations, and I know that mass is going to resist accelerations. And so we have Newton's second law, which essentially says the sum of the forces is equal to mass times acceleration. So this could also just be net force is mass times acceleration. So pretty straightforward. What we're going to do is we're going to first go ahead and open up the simulation. It's another PhET simulation. And we have a couple of things to mess around with. First, we can go to this net force. And I just have you go ahead and, sorry, I was already playing with this. Check the sum of the forces box, and then I just have you put some various scenarios where you have, different people on each sides. I have you do it with same size, different size, and 3 biggest, 2 smallest, and just kind of note if there was or was not any movement and what the sum of the forces was. Again, forces cause accelerations. This part is pretty straightforward. A couple of quick questions to answer, and then I'm going to have you go ahead and go to the motion window. In order to do that, what you're going to do is you're going to click on this little home button right here, or you can click on this little motion guy right here. And now we're going to start pushing on some cart. I do have you check all of these boxes, and do note that once the speed hits 40 meters per second, the guy stops pushing. At that point, you will need to reset the simulation. You can do it in increments of 50 newtons, or you can do smaller ones. I don't really have you mess around with the smaller ones. Now, I did really quickly reset the simulation here. So what I want you to do is to just kind of describe the position, velocity, and acceleration as this guy does his little pushing bit after you go ahead and allow this thing to play. So then what I have you do is I have you reset the simulation. Do please check the boxes again and let him push for about 5 seconds and then drop the force down to 0. I want you to then describe the motion of the box and exactly what you need to do in order to make the box come to a stop. Then what I have you do is I have you just measure the acceleration and the force for a 50 kilogram crate. I'm going to have you increase the force from 50 newtons to 100, 150 to 200. You may need to reset the program. So what I want you to do is I want you to go down here to the acceleration tab. Now we can actually get some values for the acceleration. So there we go, get my values on here. So I'm going to have you get rid of all the friction. I don't want friction playing a role. Notice that the surface changed to ice. I want you to apply that force on there and record this acceleration. I'm going to have you increase the force and so on and so forth. Again, if it hits 40 meters per second, you just have to reset the simulation. Then I just have you calculate the force divided by the acceleration right here. And you should say, gee whiz, that looks a whole awful lot like the mass. Then if we were to replace an object that is twice as massive, what would happen to the acceleration? Make a prediction. And then you're going to replace the 50 kilogram crate with a 100 kilogram water container and make the same observations.